Hi students, we are learning the chapter wave optics. In the previous lecture, we have discussed about the explanation of the phenomenon of reflection on the basis of wave theory of light. Okay, now we are going to discuss or we are going to explain the phenomenon of refraction of the light. Okay, on the basis of wave theory of light. So the name of the topic that we are going to discuss is law of refraction, refraction of a plane wavefront from a plane surface. रिफ्रॅक्शन याचा अर्थ काय आहे तर लाईट जेव्हा एका मीडियम मधून दुसऱ्या मीडियम मध्ये ट्रॅव्हल करते when the light travels from one medium to other medium it changes its path. Okay, the angle made by the incident ray with the normal is called angle of incidence, and the angle made by the refracted ray with the normal is called angle of refraction. And here we are going to define the refractive index of the medium. So this is the discussion we are going to do, and we are going to explain this phenomenon with wave theory of light, Huygens wave theory. So first of all, see what are the laws of refraction. If you see this figure, this is a denser medium, say glass, and the ray of light is coming from the rarer medium, say air. Okay, so this is incident ray, and the light is passing through the glass, so it has bent towards the normal. Remember, when light travels from the rarer medium to the denser medium, it bends towards the normal. Now this is the refracted ray. The incident ray has made an angle with the normal, that is called angle of incidence, and the refracted ray has made an angle with the normal, that is called angle of refraction. Angle of incidence indicated by small letter I, and angle of refraction is indicated by small letter R. So what are the laws here? So for a given pair of media, the ratio of sine of angle of incidence to sine of angle of refraction is constant. Means for this angle I, you find sine I, then for this angle R, you find sine R, and sine I upon sine R, this is a ratio and it is a constant, and that is called refractive index of the medium 2 with respect to medium 1. So n is equal to sine I upon sine R, and this n is called refractive index. Sometimes it is indicated as mu also. Refractive index दाखवण्यासाठी n हा पण सिंबॉल आहे आणि mu हा पण सिंबॉल आहे. Okay, and this law is given by Snell. So it is what called as the Snell's law. Now second law of refraction, that is incident ray, refracted ray, and normal to the surface at a point of incidence all lie in the same plane. Incident ray, refracted ray, and normal हे एकाच plane मध्ये असतात. Now see this figure. So this plane is separating the rarer medium with the denser medium, and here this is the normal. Now this is incident ray, this is refracted ray, and these two rays are not in this plane, but actually there is one plane which is perpendicular to this plane, that is the plane with a red border, and in this plane this incident ray, normal, and refracted ray lies. Now third law, that is incident and refracted ray lies on opposite sides of the normal. Read here properly, it is a refracted ray. This is a normal, this is the incident ray, and this is the refracted ray. So incident ray is on the left side and refracted ray is on the right side. So it is on opposite sides of the normal. So these are the three laws of refraction. Now let us explain the phenomenon of refraction on the basis of wave theory of light. So this is a surface XY which is separating the two media, the light is coming from the rarer medium and entering to the denser medium. This is a rarer medium and this is a denser medium. Now you know that the velocity of the light in rarer medium is greater than the velocity of light in denser medium. So here C1 is the speed of the light in a rarer medium and C2 is the speed of light in denser medium. Now this is a one incident ray. This is other incident ray. We call it as a wave normal also. Yes, and as soon as this wave enter into the denser medium, this ray enter into the denser medium, it will not go straight with in the original direction. It will change its direction. So it will bend towards the normal. Now this is a refracted ray and this is also refracted ray. Because light has a tendency to change its path from when travel from one medium to other medium. Now this is the incident wave front. Now it is approaching towards the surface XY. As you see here, it is coming towards the surface XY. You know, this is inclined. This has some inclination with the surface XY. So when it reaches to surface XY, it touches at this point first. Say that point as A. Okay, again it goes into the other medium. But see what happens here. This particular point, see the cursor on surface XY, that is at the this surface is separating the two media. This particular point acts as a secondary source of light and it will start to send out secondary waves. Here, wave from this point, say this is point B, and it will reach to the point C in time t. But yet, at this point, just the ray is entering into the denser medium. Now, what you observe here, this is the refracted wavefront. Now, this is a refracted wavefront. See once again, this is rarer medium, this is denser medium. These two are incident rays. We can call them incident wave normals. This is a normal, this is a perpendicular drawn to the surface XY at the point of incidence. Now this ray is refracted, this ray is also refracted. This is the incident wavefront and it is coming towards the surface XY. Now its position is A to B2, then it will come to the position A1, B1, and then it will come to the position AB. Now A is a point at which the incident wavefront reaches first. Incident wavefront आणि सरफेस XY चा पहिला एन्काउंटर या पॉइंट ए ला होतोय. म्हणजे अजून पॉइंट बी हा सरफेस XY कडे आलेला नाहीये. आता इथं युगेन्स प्रिन्सिपल काम करतो. What is Huygens said? Yes, every point on the wavefront acts as a secondary source of light and it starts to send out secondary waves. मग इथं yes. What happens here? When A2 reaches at point A, B2 reaches at point B. म्हणजे A2 हा A पर्यंत पोहोचतोय तेव्हा B2 हा B पर्यंत पोहोचतोय. ओके. Now A is a point on the surface XY, but B is not a point on surface XY. Means this particular the waves from this point B will reach to surface XY in a time t. It will take some extra time t. Understand? So that point is said C. Now this extra distance traveled, that is BC, is C1 into T. Initially, I have explained you that the velocity of the light in the rarer medium is what? C1. So velocity into time, that is distance. So it is C1T. Now, velocity of light in denser medium is C2 and C2 is less than C1. कारण denser medium मधली velocity काय असते? rarer medium मधल्या velocity पेक्षा कमी असते. टाइम तर सेमच आहे. पण इथं मात्र C2T, this product will be less. That is distance traveled by the secondary waves from source A into the denser medium will be the less. Okay? Why? Because the speed of the light in rarer medium is greater than speed of the light in denser medium. Because C1 is greater than C2, so we can say C2T distance is less than the C1T distance. Okay? Yes, for the same time T, the distance traveled in a rarer medium will be greater than the distance traveled in denser medium. C1T will be greater than C2T. So this distance BC will be greater than distance AD. Now what we have to do? आपल्याला आता काय करायचंय? So we have to take this distance C2T. Okay, we have to take this distance C to T. So during this time, secondary wavelets A cover a distance C to T in denser medium. म्हणजे जोपर्यंत B पासून C पर्यंत वेव्स पोहोचत नाहीत तोपर्यंत A नंतर काय निर्माण केले? सेकंडरी वेव्स निर्माण केलेत. आणि त्या ज्या वेव्स आहेत त्या किती डिस्टन्स पर्यंत पोहोचल्या? C to T इतक्या डिस्टन्स पर्यंत पोहोचलेल्या आहेत. Now we have to take this as a radius C to T. Take this as a radius. Take A as a center and draw this sphere. Draw this sphere. Okay. Now see, every point on this sphere and this point C are in phase. Why? Because the time required to move from B to C in rarer medium for the waves and the time required from A to the circumference here is same. So all the points on this circumference and this point C are in same phase. So let us draw a tangent CD to this wavefront. I say point D and point C are in phase, and I say all the points on in DC are in the same phase. Here AB is the incident wavefront and DC is the refracted wavefront, and it propagates into the medium, so on. म्हणजे हा DC पुढे D1, C1, D2, C2 असं करत तो काय करेल? ट्रॅव्हल करेल. Now we are going to prove this. What we are going to prove? That is sine I upon sine R is equal to N. Okay, let us see. Here, the angle A1AN. See, what is this angle? A1AN. Yes, correct. This is the angle of incidence. Yes, this is the angle of incidence. Now, angle DAN dash. Angle DAN dash. Yes, this is the angle of refraction. R, small r. And this NAN dash is the normal drawn to the surface XY. You know that C1 is the speed of the light in the rarer medium, C2 is the speed of the light into the denser medium, and C1 is greater than C2. So from figure, observe this figure properly. Angle A1AN is the angle of incidence. And if you see this, AB is a wave front and A dash A is a ray of light, or you can say wave normal. And you know that the wave front and wave normal always perpendicular to each other. Therefore, here I say angle A1AN plus angle NAB is how much? 90 degree. Out of that, this angle A1AN is I. So what we can say? The angle, yes, NAB will be what? 90 minus I. My dear students, please understand this geometry. This is very, very important. So angle NAB will be, yes. Now next is angle NAB will be what? 90 minus I. Now next, angle NAB plus angle BAC. See the cursor properly. Cursor, yes. So this much angle is how much? Again 90. This angle is also 90. Right? So if we take this, so these two things, no? Angle NAB is here and angle NAB is here. So automatically I can say angle A1AN is equal to angle BAC. Angle A1AN is equal to angle BAC. Now angle A1 AN is how much? I. So automatically angle BAC is what? I. Yes, I can say. So angle A1 AN is equal to angle BAC, and that is equal to angle I. Understood, students? You can pause the video, you can rewind the video, and you can see again. It's very important step. Okay, now angle BAC is I. My dear students, again observe angle N-AD. N-AD. Yes, this is what? N-AD, this is angle of refraction. Okay. Now, in this angle, if we add angle DAC, see here, this is N-AD and angle DAC. Definitely, this will be what? 90 degree. This will be 90 degree. Okay. Then angle DAC, plus angle ACD will be also 90 degree. See here. If you see this is CD is a tangent, okay, and AD is the radius. Now tangent and radius are always perpendicular to each other. So this angle is what? 90 degree. Now remaining two angles of this triangle, ADC. So angle A, that is angle DAC, and angle C, that is angle ACD. So they will be what? Together they will be 90 degree. Now here again what we found in these two equations, this is angle DAC, this is angle DAC. So angle NA dash, N dash AD and angle ACD both are what? Same, equal. And how much it will be? Yes, it will be equal to this angle of refraction, that is small r. Understood? Okay. Now let us remember Snell's law. What is Snell's law? Yes, N is equal to sine I upon sine R. So from triangle ABC and triangle ADC, sine I, let us define sine I. This is angle I. So sine I is what? Opposite side upon hypotenuse, that is BC upon AC. And you know BC is how much? C1 into T. And sine R, that is what? AD upon AC. And AD is how much? C2 into T. Now let us define sine I upon sine R. Sine I upon sine R. So if we take this ratio, AC will get cancelled. It will come BC upon AD. AC will get cancelled. It will come BC upon AD. BC is what? C1T and AD is what? C2T. So TT will get cancelled and the answer will come C1 upon C2. But you know that this sine I upon sine R is called refractive index of the medium and it is indicated by letter N. So sine I upon sine R is equal to C1 upon C2 and that is a constant, and hence here the first law of refraction is verified. So Snell's law of refraction is verified, is proved with the help of wave theory of light. If you observe this figure, you will see the incident ray, refracted ray and normal are to the surface are all in the same plane. Yes, and the incident ray and refracted ray are on the opposite side of the normal. So simple. Yes. So here also second and third law is also verified. My dear students, here we have explained the phenomenon of refraction of light in detail using the wave theory of light. In classroom session, we will solve numerical problems.